Hello friends, welcome back to our channel Aaj Zindagi Edu-Care. Our channel provides online learning materials for maths and science from class 8 to class 12. Please visit our channel playlist to get benefits of these free online learning materials. Okay friends, coming back to the topic functions. This is the second lecture of functions. In the first lecture, we have seen what is a function, function as a special kind of relation. Then we have seen function as correspondence. We have discussed how to find domain, codomain and range of a function. Also, we have discussed what is equal functions. Okay, friends. So today we are going to discuss real functions, domain and range of real functions, and then we will solve some problems related to this. Okay, friends. So, those who have not seen the previous lecture of this topic, please go through the part 1 of this lecture. You may follow the link given in description box or may visit the playlist to follow this part 1 lecture. Okay, friends. So, we will start with real functions. So, what is real function? If A and B both are subsets of R, then f is called a real valued function. Okay, this real function or real valued function. So, real valued function. Okay, so how we can define a real valued function? A function f a to b is called a real valued function if B is subset of R, B is subset of set R, which is set of all real numbers. Okay, R is set of all real numbers. Okay, so in other words, if a function is defined f from a to b, so we can write if a and b both, if set a and b both are subsets of set R, then f is called a real function. Okay, so we will see some real functions. If we see, we can tell that domain and codomain both are infinite subset of R in case of real functions. A real function is generally described by some formula or some general formula, and images of various elements in the domain of a real function are provided by some general formula. So some relation is given or some function fx like image will be given by fx equal to suppose x minus 1 by x square minus 5. Okay, like this some relation will be given so that one can find the image for a real value of x. Okay, so in that images and domain and your codomain all will be real set. So we will see some problem based on real function. If we see fx is given as x plus 1 by x, then we have to prove f of x, fx cube equal to f of x cube plus 3f of 1 by x. Okay, so fx is given, we can find f of x cube and f of 1 by x, then we will substitute the value and can check whether both sides are coming equal or not. Okay, so see what we can do. We will first find f of x cube. Fx is given, so f of x cube equal to x cube plus 1 by x cube. Okay, and what will be fx whole cube? Fx whole cube equal to x plus 1 by x whole cube. Okay, so we can write this fx whole cube equal to x cube plus 1 by x cube plus 3 into a plus 3 into x plus 1 by x. This we have expanded from the formula a plus b whole cube. Okay, so this we may write fx whole cube equal to f of x cube, which is x cube plus 1 by x cube plus 3 into, if we see this one, can be written as f of x cube plus 3 into fx, because fx is x plus 1 by x. Now we can see that fx and f1 by x, as we have to, so what will be f1 by x? It is equal to, we will put in the relation given, so in place of x we will put 1 by x plus 1 by 1 by x, which will be 1 by x plus x, which is nothing but fx only. Okay, so this relation we will use fx equal to f1 by x. So fx whole cube is equal to f of x cube plus 3 into f of 1 by x. This we are using since fx equal to, since fx equal to f of 1 by x. Okay, so this is what we have to prove. So let me clean this. We will see another problem. Please write down fx is given as x minus 1 by x plus 1. X is not equal to minus 1. Then we have to prove prove that f of fx, okay, f of fx equal to minus 1 by x, provided x is not equal to 0. Okay, so how we can prove this? So we will calculate as we have been given fx. Fx equal to x minus 1 by x plus 1, and x is not equal to minus 1. So f of fx, it will be f of x minus 1 by x plus 1. Okay. So in place of x we will put, this will be equal to x minus 1 by x plus 1 minus 1 divided by x minus 1 by x plus 1 plus 1. Okay. So we will take LCM x plus 1. So x minus 1 minus of x plus 1 divided by x plus 1 and whole divided by x minus 1 plus x plus 1 whole divided by x plus 1. Okay, so this will get cancelled. So what we will get, x minus 1 minus x minus 1 divided by x minus 1 plus x plus 1. Okay, so 1 will get cancelled out in denominator and this 2x will get cancelled out in numerator. So we will get minus 2 by 2x, which is equal to minus 1 by x. Okay, therefore we can write f of fx is equal to minus 1 by x, provided x is not equal to 0. Okay friends, so next we will discuss domain of real functions. Already we have seen what is domain. Now we will see domain of real functions. Okay, so in order to define the function, one should first define domain, codomain, and range of its elements in the domain. Okay, which can be done either by giving a general formula or listing them one by one. Okay, so real functions are described by providing the general formula for finding the image of elements in its domain. And the domain of real functions is the set of all those real numbers for which the expression for fx assumes real value only. So what are domain of real functions? We can write domain of real function fx is the set of all those real numbers for which the expression for fx or the formula for fx assumes real values only. Okay. So, in other words, we can say the domain of fx is the set of all those real numbers for which fx is meaningful. The domain of fx is the set of all those real numbers for which fx is meaningful. Okay. So if we say a function, will take an example. If fx equal to 3x minus 2 by x square minus 1. So this function assumes real values for all x which is an element of real numbers except denominator should not be 0. So we can write x square minus 1 is not equal to 0, or this implies x square is not equal to 1, or x is not equal to plus minus 1. Okay, so domain we can write domain of f equal to a real number set minus minus 1 and 1. So all real numbers except minus 1 and 1 is the domain of function f. Okay, because when x will be 1 or minus 1, denominator of fx will be 0 and it will not be defined. So let me clean this, then we will discuss some problems based on domain of real functions. Okay, so let's write down this. Find domain of function fx equal to x square plus 3x plus 5 divided by x square minus 5x plus 4. Okay, so what we can see, fx is a rational function and fx assumes real values for all real number x except for those values of x for which denominator, which is x square minus 5x plus 4, will be 0. Okay, so we can write fx assumes real values for all x x is an element of R except for all those values of x for which x square minus 5x plus 4 equal to 0, that is x minus 1 into x minus 4 equal to 0, or x equal to 1 or 4. So domain will be domain of function f is equal to a real number set excluding these two values 1 and 4. Okay friends. Next we will solve another problem. Let me clean this. Please write down the problem. Find the domain of functions defined by find the domain of fx defined by fx equal to under root 4 minus x under root x square minus 1. So how to solve this problem? See, we can see fx will be defined for all x excluding, so we can write fx is defined for all x satisfying 4 minus x should be greater than equal to 0. Okay, as if 4 minus x is greater than 0, then only we will get real roots of this, and x square minus 1 is greater than 0. See, for x square minus 1, it should not be equal to 0, as in denominator then it will become 0. That is when x equal to 1, it will be 0. So here equality does not hold. So we can write x minus 4 will be less than 0. Multiplying by minus 1 both sides, it will change the sign. And x minus 1 into x plus 1 should be greater than 0. From this we can write x is less than or equal to 4, and from the second relation we will get either x is less than minus 1 or x is greater than 1. Okay friends, see x minus 1, if we plot this on the number line, and this will be your minus 1 1. So when x is greater than 1, okay, so this will be positive, this will also be positive, so it will be positive. And when x is less than minus 1, so it will be negative, and this will also be negative. So here also it is positive, and in between it will be negative. So either x is less than minus 1 or x is greater than 1. It implies x is an element of minus infinity to minus 1. Minus 1 will be open because this will satisfy both x is less than 4, so it is also less than 4. Union x is greater than 1, so from 1 to 4, and 4 equality will hold, so it will be closed down. Okay, so domain of function fx is equal to minus infinity to minus 1 union 1 to 4. Okay friends, so these are problems related to domain of a function. Next, we will discuss range of real functions. So let me clean this. Range of real functions. Okay. So the range of real function is the set of all real values taken by fx at points in its domain. So in order to find the range of a real function, we may use the following algorithm, which may be written as just I will write the range of a real function of a real variable is the set of all real values taken by fx at points in its domain. Okay. So in order to find real function, range of real function, so we will write algorithm for finding range of real functions. Okay. First, what we have to do, if a function is given as fx, so we will put y equal to fx. Then solve the equation y equal to fx for x in terms of second. Solve y equal to fx and express x in terms of y, or x equal to as a function of y. Okay. Third one, find values of y for which the values of x defined by x equal to phi of y. Okay, this is x equal to phi of y are real and in the domain of f. Okay, so whatever is obtained from the above state, so say all values of y obtained is range of f. Okay, friends. So we will try to understand how to find the range of real functions by doing some problems. So this is the algorithm. First we have to assume y equal to fx and then express x in terms of y, or express x as a function of y. Then we have to find the values of y for which this function will be real. Okay, and all the set of values of y is range of f. So we will discuss some problem. So please note down this problem. Find the domain and range of the function. Find domain and range of function fx given by fx equal to x minus 2 by 3 minus x. Okay, so how to find domain and range? As we have discussed already, how to find the domain. So we can clearly see first one we will find domain. Okay, domain of fx. If we see fx equal to x minus 2 by 3 minus x, so fx is defined for all x except 3 minus x equal to 0. So we can write fx is defined for all x satisfying 3 minus x is not equal to 0, or we can say x is not equal to 3. Okay, so domain of f equal to real number say minus 3. So all real numbers except 3. Then we will try to find range of fx. Okay, so as we discussed now, as per algorithm we have to take y equal to fx. Then we will try to express x in terms of y. So y equal to x minus 2 by 3 minus x, or this we can write 3y minus xy equal to x minus 2. Then x we will bring on one side, so x into y plus 1 will be equal to 3y plus 2, and from this we will get x equal to 3y plus 2 by y plus 1. Okay, so x assumes real values, real values for all y except y plus 1 equal to 0, that is y equal to minus 1. So range of f is real number say excluding minus 1. Okay friends, so we will take another problem. Please write down. Find the domain and range of the function given by fx equal to x square minus 9 by x minus 3. Okay, So clearly we can see, in order to find domain, x should not be equal to 3. So how to calculate domain of f? Okay, fx is not defined clearly. Fx is not defined for x minus 3 equal to 0 or x equal to 3. So domain will be real domain of f, real number set excluding 3. Okay. Next, in order to find range of f, okay, we will assume y equal to fx, and from this y equal to fx is given as x square minus 9 by x minus 3. So we will try to express x in terms of y. So y equal to this we can factorize as x minus 3 or x plus 3 divided by x minus 3. So y equal to x plus 3 or x equal to y minus 3. Okay. So we can see that y takes all real values except 6. So we can write y can take all real values except y equal to x plus 3 when x equal to 3. Since x is not in domain, so when y equal to 3 plus 3 equal to 6, therefore range of R of f equal to real number set minus 6. Okay. So in this way we can find domain and range of a given real function. Okay friends. So today we have discussed what is real functions, then how to find domain and range of real functions, and then we have discussed problems based on domain and range of real functions. Okay friends, I hope all of you have understood. If you have any doubt or any query regarding this topic, please let me know in the comment box. And if you have seen the whole video and liked it, please like the video and subscribe our channel if you have not subscribed till now. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.